Hello, I'm Logan Woudstra, and I'll be introducing you to our work identifying emotional and polar concepts via Synset translation. So, in this work, we explore two tasks. The first is that of polarity classification, which seeks to determine the polarity of a piece of text. For example, we can classify the word murder as having a negative polarity. The second task we explore is that of emotion identification, which seeks to determine the specific emotions from predefined inventory that best reflects the meaning of a piece of text. Again, looking at the word murder, we can identify it with the emotions of anger, fear, and sadness. Now, in this example, we are assigning sentiments to a word. However, in general, assigning sentiments to words is ambiguous, as words can be polysemous or have multiple senses. For example, let's look at the word lick, which has three different verbal senses. The first sense means to pass the tongue over and could be associated with the emotion of disgust. The second means to be thoroughly and conclusively in a fight, and could be associated with the emotion of anger. The third means to find the solution to or understand the meaning of, and could be considered non-emotional. If we were to assign a sentiment label to the word lick, we would have to simultaneously express the emotions of all three different senses. So we might say that lick is associated with both anger and disgust. But this third sense is associated with neither of these emotions, so there exists some ambiguity. To avoid this ambiguity, we can label synsets rather than words. Now, a synset is a set of synonymous word senses that express a distinct concept. We make use of the lexical database WordNet, which contains English words that are grouped into over 117,000 synsets. Below here, we have the WordNet entry for the three verbal senses of lick that we're just considering. This top sense expresses the concept to be thoroughly and conclusively in a competition or fight. Now, this synset contains not only the English word lick, but also the words cream, bat, clobber, drub, and thrash. So rather than trying to ambiguously label all six of these polysemous words, we can instead assign a single label to the synset and say this is a synset that's associated with the emotion of anger, and this is a much more clear way to assign sentiments. So there already exist resources that assign sentiments to synsets. For emotion identification, there exists WordNet Effect and SentiSense, which each contain a few thousand emotional synsets. However, these resources are based on differing emotional inventories that are mutually incompatible with one another, with one using 36 emotions, while another using only 14 emotions. Both of these resources were developed through a similar semi-automatic process, which involved first creating a core of manually annotated synsets through human annotators. This core was then automatically extended. However, these resources have very limited coverage, covering at most only 3,000 out of the total 117,000 WordNet synsets. And this is largely due to the fact that they rely on a manually annotated core that takes time for humans to develop. Turning our attention to polarity classification, the most prominent resource is SentiWordNet. Now, SentiWordNet assigns all WordNet synsets a positive, negative, and neutral polarity score automatically. However, with this complete coverage, means that the predictions are going to be less accurate, and this is because the classifier is forced to make a prediction even when it's not confident. So we try to address some of these limitations that exist in previous work. With our approach, we try to automatically resolve ambiguity regarding polysemous words by utilizing multilingual translations, and this idea is based on the two following assumptions. The first is that emotions are associated with concepts, not words. And this is the same assumption used to create any synset level lexicon. The second assumption I make is that the emotions associated with concepts are universal across languages. So the sense of lick, meaning to pass the tongue over, is associated with the emotion of disgust, not only in English, but also in Chinese and Polish and Igbo and all other languages. Now, we recognize that this assumption is not always true, and there exist counterexamples to it. However, we find that it holds quite often, and it holds consistently enough that we are able to produce a useful lexicon using it. So below, we have an example that highlights how we can leverage multilinguality to resolve the ambiguity regarding the three senses that we were looking at before. So all three of these senses are associated with a single English word lick. But if we pass them into a translator, we can find that they're associated with 3 distinct Dutch words: likken, ranselen, and oplossen. And if we look up each of these words in a Dutch sentiment lexicon, we may find that likken is associated only with the emotion of disgust, ranselen is associated only with the emotion of anger, and oplossen isn't associated with any emotions at all. And this is how we can resolve some ambiguity using multilinguality. So this is a overview of our multilingual method, where we're trying to classify the example input synset that expresses the concept needing to be marked by intense convictions, inclined to react violently, that contains the English lemmas of fierce, vehement, and violent. Now, these English lemmas are associated with the emotions of anger, fear, and surprise, and we're trying to determine which single emotion best expresses the sentiment of the synset. So we pass the synset through a translation source and get the multilingual lemmas that belong to the synset in a variety of different languages. In this example, we look at 7 different languages, but our actual method makes use of 20 different languages. We then look up each of these lemmas in a multilingual sentiment lexicon to create this table down at the bottom, which contains the emotions and polarities of the multilingual lemmas in all these different languages. To predict which emotion or polarity to associate with the synset, we see which is the most common among these among the table. So in this example, we find that fear is the most common emotion, and it appears in 5 out of the 7 languages. So we predict that the synset is associated with the emotion of fear, and the confidence of our prediction is 5/7, which is roughly 0.71. Similarly, we find that negative is the most common polarity, and it again appears in 5 out of the 7 languages. So we predict the synset to have a negative polarity, and the confidence of our prediction is again 5/7, or roughly 0.71. Now, you may notice that in this figure, we just use a general translation source and a general multilingual sentiment lexicon. But what are the specific resources that we actually use? Well, for the translation source, we make use of BabelNet. BabelNet is a multilingual resource that is constructed by integrating various existing lexical databases together. These lexical databases were developed by experts, so they provide highly accurate translations for synsets. For the multilingual sentiment lexicons, we make use of the NRC Word and Motion Association lexicon. Now, this is a resource developed by human annotators that contains over 14,000 words that are associated with 8 different emotions and 2 different polarities. This resource was originally developed in English, but has since been translated into 108 different languages. So we run our multilingual method on the entirety of WordNet, all 117,000 synsets. And the synsets that we predict to be emotional and polar with high confidence constitutes our lexicon's core. Now, just like WordNet Effect and SentiSense, we automatically extend our core using emotion-preserving WordNet relations. In particular, we make use of the antonym, similar to, derived from, pertains to, attribute, and also sees relations. So, going back to the adjectival sense of fears that we predicted to be associated with the emotion of fear and to have a negative polarity, since this synset is similar to an adjectival sense of intense, it's derived from a nominal sense of fierceness, and it pertains to an adverbial sense of fiercely, we say that all of these synsets are now predicted to be associated with emotion of fear and a negative polarity because of their relations. So after we extend the core of our lexicon, once we extend the core, we derive a lexicon, which we call SentiSynset. Now, SentiSynset contains over 12,000 emotional synsets and over 15,000 polar synsets. If we recall back to the other resources that contain only 2,000 or 3,000 synsets, we can recognize that our resource is significantly larger. As well, we compare the accuracy of the labels of our method to that of other automatic methods. So we compare to 2 baselines as well as 2 resources. So the resources I compare to are the polarity labels of SentiWordNet, as well as we prompt ChatGPT with the lemmas and gloss of the synset to provide emotional and polar labels. And we find that our method provides the most accurate labels out of all these automatic processes. So in conclusion, we leverage multilinguality to develop an automatic method that assigns emotional and polar labels to word senses. We also created SentiSynset, which is a sense-level sentiment lexicon that is significantly larger than comparable resources. Finally, the labels assigned by our method have high precision. So if you'd like to access our resource SentiSynset, you can do so at the following GitHub repository. Thank you for taking the time to listen to this presentation.